Welcome to Study Loop.
Okay, so I'm not sure what the question is here. The text that I see just says H20 Lewis structure without minimizing formal charges. It's not really a question, it's a statement. Um, and let's talk about this. I mean, I think I can give you some guidance on maybe what you want to do. But the thing is that H2O doesn't have any formal charges, right? So if we want to do a Lewis structure, usually the first thing we do is figure out how many electrons we have to work with. Hydrogen, which is in group 1A, brings 1 electron each, and oxygen, which is in group 6A, brings 6 electrons each. If we've got 2 hydrogens and 1 oxygen, we should end up with 8 electrons. Okay, next we know that hydrogen is always terminal. That is, we always find hydrogen on the end, no matter what atom we're talking about, and we never have, for example, a hydrogen with 2 bonds, right? Hydrogen always has a single bond, and if there's other atoms, those atoms would have to be the central atom. Hydrogen can't be a central atom, it must be terminal. For that reason, we already know that at least the skeletal structure before we apply any lone pairs looks like this. We've got oxygen with a bond to hydrogen on one side and a bond to hydrogen on the other side, right? So this is just the starting point using what we know about hydrogen when it's in a Lewis structure. Okay, now at this point, what I would do is I would figure out how many electrons we've used just building the skeleton and then move on to applying additional bonds or lone pairs. So at this point, we've used 2 electrons here and 2 electrons there for a total of 4 electrons, meaning we have 4 electrons left as well out of our initial 8, right? Now we also know that hydrogen has a valence of 2. That is, it only wants to see 2 electrons, which means it always just has a single bond and no lone pairs. So hydrogen doesn't want any more electrons. Both the hydrogens are fully satisfied, which implies that any additional electrons we have will go to oxygen, and that they will go to oxygen as a lone pair and not as bonds, because any additional bonds would surpass the valence of hydrogen. So we know that these 4 electrons must be a pair of lone pairs on oxygen. Right? And now we'll point out that at this point, usually you would start to calculate formal charges and see if there are perhaps alternate structures that minimize the formal charges you have on any atoms. Well, in this case, hydrogen, right, is in group 1A, and it sees basically 1 electron from this bond, right? And so it's satisfied, it doesn't have any formal charge. The same is true of the other hydrogen, which just sees like 1 electron. It's in 1A, so it's satisfied. And then we consider the amount of electrons that oxygen sees. Oxygen is 6A, right? Which means that it wants to see 6 electrons. And it sees 1 from this bond. It sees 1 from this bond. And it sees all 4 of the electrons that are in its lone pairs, which means it sees 6 electrons. Right? If it had seen 7, it would have a negative charge. If it had only seen 5, it would have a positive charge. But in this case, it sees exactly as many electrons as are its group number. Therefore, there's no charge on oxygen. And in fact, there's no way to draw water without surpassing the valence of either hydrogen or being not meeting the valence of oxygen for it to have a formal charge, right? So there is no alternate structure to consider. There's only one possible structure for water, and that structure does not have formal charges.